Hey everybody, Brian Beeler coming to you from the Storage Review Lab alongside Kevin O'Brien, and today we're looking at one of the servers that we've had in our backlog for a little while. We finally got into the review and we're excited to do it. It's the Dell EMC PowerEdge R6525 1U dual proc AMD server. What stands out to you with this guy?
There are a ton of configuration options, and actually more than the Dell website currently lets you configure.
Yeah, and that's what's a little bit odd with this, and we'll get to some of that, is that when Dell released this second-gen EPYC platform, it was a transitional process. So the first ones were configured a certain way, and then over time, over the summer really, Dell's been able to enhance the offering a little bit with Gen 4 support, for instance, in the front bays if you get the NVMe option. But it's been, like I said, transitional. So what you saw earlier in the year is a little bit different than what's available now, and this one kind of sits somewhere in between. But let's talk about that. Let me start by sliding off the bezel. Ours has got the display on it, which is kind of nice. They also have the Open Manage mobile compatibility with these for provisioning.
It's called QuickSync.
Yeah, QuickSync, where you can, it sets up the little Wi-Fi hotspot, or what does it even do?
Well, it creates a very short-range Wi-Fi connection, and I think you'd also connect into it through mic USB, but it allows you to, instead of having to wheel around a crash cart, you could deploy servers from a mobile phone, a tablet, a notebook, that sort of thing. Yeah,
and manageability at scale is important for servers like these, and especially the 1U guys that tend to be real dense compute platforms. It's not like many people are buying one of these. They're normally going to be half a rack or whatever, yeah. So that helps from a manageability standpoint. So our guy, we've got 10 SAS drives. We've got 8 SAS drives, 6 SAS drives, and 4 NVMe drives.
Well, we tested 6 and 4, or I should say we only tested the 4 NVMe, but this particular backplane supports 4 NVMe devices and 6 SAS, or maybe it's 10 SAS, but 4 bays for NVMe.
There's a lot of flexibility.
Yeah.
And actually, let's take a look at some of that. So if we look at the top line configurations of the Dell PowerEdge family, we've highlighted the 2 that are the AMD platforms. So we've got the 6525. The 7525 is the 2U version. They're both dual proc systems, but can be configured with a single processor if you so choose, I suppose.
Yeah, I'm not sure who's going to buy one of these to grow into in that way, but it's an option.
You can, and of course those sit alongside the more robust Intel family. As we were talking about, there's a couple different options as you go through the configurator on what you can do with drives. You could slam some 3.5-inch hard drives in here if you want. We do see that from time to time where these are used for analytics and somebody wants more capacity in the front of these things.
Yeah, and it should be said that this is just the tip of the iceberg when you start working on configuration, because
these are quite literally the first 2 options.
Yeah, you select them and it's like, okay, well, NVMe backplane, but then it rolls into how do you want that configured? Do you want 10 in the front? Do you want 2 in the rear? I mean, there's a lot of different options for just these types of sizings.
Yeah, and it's the flexibility is great, but like you said, there are a number of different options. And when I was playing with the configurator yesterday, it's the 10 plus 2, because you can put the 2 NVMe drives in the back, was kind of buried, and you had to come, walk me through the process because there's so much. One other thing I did want to highlight here is with Gen 4 support, these are the drives that are currently in the configurator. Of course, the pricing is going to change. The reason I highlight this, though, is I think is important, because when you look down the list of SSDs supported, now this one doesn't say what drives these are. If you look at the Gen 3 drives, it's pretty clear which ones are Intel and which ones are Samsung. Yeah. These could be, they could be anything, Intel, Samsung, Kioxia, or SK Hynix. But the pricing is what's really interesting, because I think a lot of people think Gen 4 SSDs and they think it's expensive. What we're highlighting there is that for similar, those prices that we showed are very similar to what the Gen 3 prices are, and in some cases the Gen 4 drives are less expensive.
Yeah, I mean, we're seeing that already, where the newest offerings in capacity, density is all going on Gen 4 only, which you could say a lot of the Gen 4 drives are backwards compatible, or almost all of them are backwards compatible. why not just go with that for the latest and greatest? And we're seeing certain vendors just start putting their newest offerings on Gen 4 only.
Right. So the street prices might be a little different if you're configuring your own server, but in the Dell configurator, just be really sure that if you're looking at something like this, especially that supports Gen 4, that performance delta is massive. So there's,
your read bandwidth differences, I mean, it's going to be double.
right. So there's absolutely no reason to not spend the little bit more, or in some cases a little bit less, for the Gen 4 drives. So as we take a look at the other configuration options.
This guy is where it gets fun, because if you're looking, when we're first looking at this, you look at the back and there's a number of little slots, and you can get quickly mixed up on which ones are the OCP slots, which are the PCIe slots, and then how they're consumed based on what the drive configuration is.
Okay, so real quick before we get to the back risers, and we'll do that, let's walk through the rest of this front to back.
Yeah, so
this is an interesting mounting decision.
Yeah, and we'll see this theme throughout this particular server, where there's a lot of unique aspects to how Dell configured this. For one, the RAID card sits up front in this server,
right.
And it basically has quick and easy access to the SATA and SAS bays, and it just gets it out of the way from a lot of the things that go in the back.
Well, right. There's not much wasted space here, and that's actually one of the compromises, right? Because you really would have liked to have seen an M.2 boot drive on board, and I know we'll get to it in the risers, but there's not a ton of room here. There's a little gap in the back, there's a little gap over here, but it's dense, right?
Yeah, and one advantage with in a lot of these servers, there's usually a big dead space right between the area between the backplane and the
right.
fans. And one of the advantages with putting all of the RAID card stuff up there is usually you have, this is going to be your coolest area in the server, but it's not just the benefit to the RAID card itself, but by moving it into the front instead of having the back, there's more space for air to flow through as it moves in the back of the server. So you end up having increased performance on the cooling capabilities where it might have been cramped from trying to fit that somewhere back here.
So speaking of cooling, we've got 8 fans, even though it looks like just 4. These are double fan modules. So those run across the front, obviously pop out really easy
and they're
to
nice and
swap out.
quiet. I mean, we've seen some servers that get sketcy on their cooling profiles.
Sure.
Dell does a fantastic job where if the server's not using a lot of load, it keeps things nice and quiet. And then even if it starts ramping up, it's not a ear-bleeding type scream from the fans.
That's good. I don't like my ears to bleed. Unless I want them to. 2 AMD processors here. We've got 16 of the 32 DIMM slots populated. You've got, what, 512 in here total?
Yes.
Okay. And as we move to the back, we've got power supplies on the edges. But let's pop some of these risers and take a look at that, because back to this slide we're looking at, these are a vast array of configuration options, which is a little overwhelming in the documentation, because I think it's the difference between half height, half length bays versus full size bays versus OCP bays. It gets a little bit confusing in the configurator.
Yeah, and it really comes down to how you want to leverage the platform, because maybe you need some full height bays, or you need half height, or your interest is more towards half height but an increased number. So, and then some of it comes down to, do you want to fit more drives versus edge cards? So there's a lot of different options here.
Right, so this riser you popped out has got the boss card in it, one of the bays, right?
Yeah, and the boss card consumes one of the bays, so even though it's not really mentioned in the configurator, it's more of like you want a boot drive, but it doesn't. There's always compromises on how you want to leverage a platform.
Especially the one used that are really dense, right? Because that's why Kevin was kind of grumpy about not having an M.2 on board, because if you go with the boss card, which can give you 2 M.2 drives either in RAID 0 or RAID 1.
Or JBOD or RAID 1.
JBOD or RAID 1?
Yeah, so you get an option where you can either access each drive individually
okay.
or in a RAIDed protected form.
Right, so that'll give you your boot area, but you sacrifice a PCIe slot, and one of our other slots has a fiber channel card in it, so that's an issue because we're just down to 1 now. And if we wanted to put, a T4 or something in there, that's great, but our connectivity is somewhat limited. Now, they do mitigate that a little bit by the OCP slot here in the back. Let me slide this guy out. And so this is, what is this, the Broadcom card? But there are many others.
Yeah, you can. There's options from 2-port of 10 gig, quad port 1 gig, and I think I even saw a quad port 25 gig option.
Yeah,
So
they go up to 25 gig in the OCP slot. I think the point is that it's about planning and making sure that you're putting the right resources in the right spots. So you can use the OCP slot, get 25 gig if you like that particular card or option or whatever is available.
It is interesting, though, where when the AMD servers first came onto the market, they were looked at as more of the value offering, and now it's more of a restructuring where this really does seem to be more of the top-tier performance model.
Well, clearly from not just the core count, but the processing power that we've seen, not just from Dell, but from the other systems that have come in that we've reviewed with AMD inside, especially Gen 2 EPYC, they've been really strong.
Yeah.
So on the riser side, though, just to finish that thought, anything else there that's worth considering?
Not really. I mean, it really comes down to make sure you plan well, because I don't know if you could really restructure this after you deploy a build.
Okay. All right, so then let's take a look at performance. Just as a quick reminder, I already jumbled up the bay count in the beginning, but you tested for these charts for NVMe Micron 9300 SSDs.
Yeah, all of our tests focused around NVMe performance, because when you're looking at the processors and RAM configuration that you have, I mean, no one's going to be putting that on hard drives or even SAS really these days. The focus is going to be on NVMe.
Okay, but before you get into that, I just went into the whole thing about how important Gen 4 SSDs are.
Yeah.
And we didn't test with Gen 4 SSDs, which I know we have because I see a pile of Hynix and other drives in the lab.
Yeah, so there's an interesting nuance with the server where early production builds apparently had a cable for Gen 3 support that can get swapped out for Gen 4 support. And I believe it's this guy right here. And we have been trying to figure out why our drives only negotiate at at the PCI Gen 3 speeds versus Gen 4, and everyone keeps on going back to it's probably an early rev cable.
All right, so we might have an early rev, but it's important that it's fixable, probably, with a new cable, and that's actually somewhat unique. So as I was saying at the beginning, as Dell rolled this out through this year, that there was a migration somewhere along the way where the Gen 4 support came along natively when you select that NVMe backplane. In a lot of the other servers that we've seen from other brands that don't offer Gen 4 support in those front bays, there's no path to get there.
And even if there was, I mean, if you look at some of the platforms that we've seen with like 24 bays of NVMe, you open it up and there's probably, I think each bay has 2 thin wires that go to it that's kind of routed around the chassis. You'd probably be spending the good part of a day to upgrade that versus this guy, which one cable and take out a little brace for a fan, or actually pop out this guy that just swings up.
Right.
And you could swap it out in maybe a minute or so.
Sure. Easy stuff. So just as a point of clarity, that's why we don't have Gen 4 drive data, although we hope to resolve that in the near future. We didn't want to hold up the review, though, in getting this out, because even with the older SSDs, it's still a highly competent platform. So I'll let you get back to the charts now.
So the big thing to take away with the performance, it is fantastic. And to get an idea of how well these numbers are, the only thing that we've tested that's higher than our 16 VM count of suspension this test is a quad CPU platform that we had in that was either 4 or 5U, and it was expandable to 8 CPU. You might know what it is. It was the SR950 from Lenovo, but it was a very stout Intel platform.
That's many more U's than this.
And that thing only got 500 more transactions per second in the 16 VM score. So this thing is an absolute powerhouse. And obviously all the other dual proc AMD platforms are going to be the same type of deal. And it really just goes to show you that these things are no longer the value offerings that everyone is trying to position them as when they hit the market.
Definitely don't have to be right now. With these CPUs are absolute beasts when it comes clearly here to transactional performance.
Yeah, and then we go to our SQL Server performance. Yeah, this is one where it topped out the test. Our test tops out at 1 millisecond for Benchmark Factory, and this guy at a 4 VM and 8 VM load, 1 millisecond. And it was 1 VM per a drive for 4 VMs and then 2 VMs per drive for 8 VMs. So evenly balanced across our, again, Gen 3 drives, but there's a lot of cool stuff that you can do with this. So when we get down to our sequential bandwidth test, this is an area where we would have higher numbers if we were testing Gen 4 drives.
Right.
So with sequential read, we topped out at it was like 12 gig a second, although you could get higher numbers than this with more drives of Gen 3. So if you had a 10 drive or 12 drive configuration, you might not notice that much of a difference. But for the smaller drive counts, where you're probably going to try and find a balance between NVMe for performance workloads, maybe some drives for logs or something like that, you might not have NVMe for everything, and that's where concentrating that workload and having high performance comes in. So if you had Gen 4 drives, you'd probably be looking at double the bandwidth there. So instead of like 12, 13 gigs a second, you'd be sitting probably north of 20 gigs a second.
Okay.
And then the small block throughput, again, this is another area where we have some Gen 4 drives in right now. They're good for like 1 million IOPS each. This guy with our 4 Micron 9300 drives got a little bit over 2.5 million IOPS read and just under maybe 800,000 IOPS write. But a lot comes down to the drives that you pick, and if you go Gen 4, you're going to be getting higher numbers across the board.
Okay. So when we think about the capabilities of this platform, clearly CPUs are great. 512 memory helps to drive this thing. It supports up to, I think, 4 terabyte in the LRDIMMs and 2 in the regular. I mean, can you imagine filling this thing with that much memory?
Would it weigh any more though?
Because it would weigh, a little bit more, and then pile it full of Gen 4 SSDs, and in 1U, from a pure computational standpoint, for all those high-end AI workloads, analytics, that sort of thing, this thing would just crunch.
You're going to be hard-pressed to find a more higher-performing platform that's not another dual-proc AMD server.
Right. And that's the great thing. And the question is then, is Dell the best choice for that category? And you will pay a little more for a Dell server. There's no doubt about that. But you get so much out of it. You get iDRAC, lifecycle controller. You get the bezels with Wi-Fi if you want it. You get all these other management and
even serviceability. You look at how a lot of the maybe tier 2 servers are laid out, or the traditional white box platform. Yes, you're going to be able to benefit on cost savings early on, but through the product lifecycle, you have to worry about how you're going to restructure your driver and firmware layer across everything installed. Dell, you can do that with one utility, and it does everything for you if it's a Dell product.
Right, and it's one of the best out there across all server platforms. So
yeah, actually, I'm going through that process right now on some of our R740s, and it takes me maybe 20, 30 minutes a server, and it's updating everything.
Right. So great platform, especially now the modern one that's shipping today with the Gen 4 support on it. If you're looking at that, like I said, make sure that you're pricing those Gen 4 SSDs. It's totally worth it. And in fact, in some cases, like I noted, is less expensive than the Gen 3 SSDs. So definitely make those at least a couple part of the configuration if you really want to drive the best performance you can out of this box. Overall, we're big fans, and we think you will be too if you go with an AMD platform. This is a great one to be. Thanks for tuning in.